Okay, so in the last video, I talked about what the power rule was. In this video, I'm just going to give more of a visual representation with a formula and just lots of practice with power rule questions. Okay, so if we're taking the derivative, so d by dx, of some polynomial, we can call it a for the coefficient times x to the n. Okay, so the derivative of some polynomial a times x to the n, right? That's where that power comes from. The n is your exponent. That's going to be a times n. So remember, we're bringing the n down to the front, multiplying into that coefficient of a times the x that we had before to the power of n minus 1. So even though this looks it looks like there's a lot of operations going on here, all we're doing is bring the n down, multiplying it by the a, and we're reducing this exponent's value by 1. So just to start off here, if we were finding the derivative of x cubed with respect to x, right? There's an imaginary 1 in front of the x cubed, so it's going to be 3 times 1. That's that a times n. So 3x to the power of n minus 1. N was 3 before, so it's just 3 minus 1, which is 2. Okay, let's do another example. Let's do d by dx of 12x squared. Okay, so we're going to bring the 2 out front, multiply it by 12. So this is really 2 times 12, x to the 2 minus 1. So this is going to be 24x to the first, or just 24x. Okay, what's another one? Let's do the derivative with respect to x of 3 over x. Okay, so even though this isn't a polynomial, it's a rational expression, we can write it as a power. Okay, so this is equal to the derivative with respect to x of 3, which is what we're multiplying 1 over x by, right, times 1 over x. So 3 times 1 over x is just 3 over x. And 1 over x, we can write that as a power of x to the negative 1. So anytime we have 1 over x, that's just whatever's on the bottom, which is x to the power of negative 1. Okay, so now that we have it in this form, this is our a times x to the n. Our a is 3, the coefficient, our x is the variable, and our n is negative 1. So remember, we bring out the exponent to the front. So this is going to be negative 1 times 3, so negative 3, times x to the power of n minus 1, so negative 1 minus 1, which is negative 2. So this is going to be negative 3. Remember, to make that positive exponent, we just divide by x squared. So x to the negative 2, that's the same as a 1 over x squared. Negative 3 times 1 over x squared is just negative 3 over x squared. Okay, let's do a square root example. Lots of people see square roots and they don't think we can write them as powers, but we actually can. So let's do a simple example. What's the derivative of the square root of x? Well, we can write the square root of x, right? The x inside has an exponent of 1 on it. The index of a square root is 2. So remember, we can write this as a power, x to the power of 1 over 2. So this is the 1, the x to the power of 1, and the fraction of our exponent, the denominator, is just going to be the index of our radical. So the derivative of x to the 1 over 2, remember we bring the 1 over 2 out in front, so this is going to be 1 half x to the power of 1 half minus 1, right? Because we're reducing the value of the exponent by 1. So it's 1 half x to the power of 1 half. Let's make this 2 over 2, so we have a common denominator. So this is 1 half x to the negative 1 half. And remember, if we want to make this negative exponent positive, we just make it a fraction. So 1 half times 1 over x to the positive version of the exponent we had. So this is 1 over 2 root x, because remember, x to the 1 half is just the square root of x. So the derivative of the square root of x is 1 half times 1 over root x, so 1 over 2 root x. Okay, let's do a cube root example. Actually, no, let's do a bit of a harder one. Let's do d over dx of 15 times the 7th root of x to the 4th. Okay, so we can write this as a single power, 15x to the 4 over 7, right? So the 4 here is the numerator of our fraction and the exponent. 7 is the denominator. Okay, so we can bring this fraction down, this fraction and the exponent down to multiply into the 15. So it's going to be 15 times 4 over 7 times x to the 4 over 7 minus 1. Okay, so 4 over 7 minus 1, actually no, let's do 15 times 4 over 7. So 15 times 4, that's going to be 60. So this is 60 over 7. That's not going to reduce. Okay, because we can't divide 60 by 7. And then we got x to the power of 4 over 7. Instead of minus 1, let's multiply the 1 by 7 over 7. Right? So it's going to be minus 7 over 7. This is going to equal 67ths x to the power of, well, 4 minus 7 is going to be negative 3. And remember, when we subtract or add exponents, the numerator or the denominator stays the same. So it's going to be negative 3 over 7. Now let's write this as a positive exponent. So this is going to be 60 over 7 times 1 over x to the 3/7. Okay, so this is going to be 60 over 7. And if we write it as a radical, 7 times the 7th root of x cubed. So they can look kind of weird, but this is ultimately your solution there. Okay, and let's just do one more. Let's do the derivative d by dx of the square, or no, let's do the cube root of x to the 5th plus 16x to the 4th. Okay. So with the properties of derivatives that we know that we can separate these two functions, these two expressions, into separate derivatives. So we can take the derivative with respect to x of the cube root of x to the 5th plus the derivative of 16x to the 4th. Okay. So writing this radical on the left here as an exponent, or as a power, this is going to be x to the power of 5/3, okay, plus d by dx, 16x to the 4th, okay. So when we bring this 5/3 down to the front, according to our formula, we're going to get 5/3 x to the 5/3 minus 1 plus this 4 is multiplying into the 16. 4 times 16 is 64, so it's going to be 64 to the power of x, or sorry, times x to the power of 4 minus 1, which is 3. Okay, this exponent here, we can just make the 1 3 over 3. So it's 5/3 times, times x to the power of 5/3 minus 3/3. Remember, that's still just 1, plus 64x cubed. Okay, so we got 5/3 x to the power of 2 over 3 plus 64x cubed. And x to the power of 2 over 3, that's the same as the cube root of x squared plus 64x cubed. So we started with the cube root of x to the 5th. We ended up with the cube root of x squared times 5 over 3 for that first part. And then we summed the two derivatives together. The derivative of the second one was just 64x to the 3rd using the same power rule. So that's kind of the main idea with power rules. That's your formula there. It should work for anything you can write with a power, right? And sometimes we're not going to be adding two derivatives two derivatives together or subtracting, we can be multiplying them or dividing them. And in my next couple of videos, I'll be talking about the power rule, or sorry, the product rule and the quotient rule when we're not just adding or subtracting two derivatives, we're multiplying or dividing them. But we're still going to be able to use this power rule throughout a ton of harder calculus problems. And this kind of just lays the foundation for how to use it. So hope you enjoyed, hope you learned something, and I'll see you in my next video.